In addition to the entities we already had, we will now add another one that will allow us to register each country, which will include information about its cities. For example, Brazil with these 2 cities, France with this city, and China with these 3 cities. So a new entity appears, country. What differentiates it from the ones we have seen so far is that, in addition to flat information such as the country name, we will have to represent repetitive information, such as the name of its cities. The cities could then be thought of conceptually as a sub-entity, but they are part of the entity that defines them and cannot exist without them. It will then be a transaction, country. With a screen like this, here we are looking at the country with identifier 1, and name Brazil. This is its flat information. And among its multiple information, we see 2 cities, Rio de Janeiro and second São Paulo. If we move to the next country, we see country 2, France, with a single city identified as 1 and named Paris. And if we look at the next country, it is 3, China, with cities 1, 2, and 3, with the names shown there. In short, the cities are entered and manipulated through this grid, which allows you to enter as many cities needed, without limit, for the country being edited. That is, we cannot enter cities independently of a country. The cities will always belong to the country currently being edited. So if we want to identify, for example, the city of Shanghai, we will have to provide 2 identifiers, the country ID plus the city ID. In this case, it would be the ordered pair 3-2. How do we represent this entity in GeneXus? We will use the assistant. What we want is a country transaction. Transaction where cities are entered right there in line. That is, within the same layout of the transaction. This is one possible description of what we just saw. We could also say a country transaction that has cities as a sublevel, or that has an inline city grid, or that allows entering cities on the same screen, or even shorter, that has inline cities among other possibilities. Let's choose any of the alternatives. We get this answer. The result is that it created the country transaction with this source, which hasn't been saved yet, so if we close the window, there will be no trace of the transaction in the KB. Let's look at the new syntax, used to represent the sub-entity of cities. Let's go to the structure to see the graphical representation. In addition to the attributes country ID and country name with the domains that we had defined in the KB, there is a sublevel called city, with attributes city ID and city name. This sublevel, or second level, will be represented in the layout as a grid. Inside this grid control, we can see these 2 attributes, city ID and city name, each in its own column, which at runtime will look like this. If we save, we see it now appears in the root module of the KB Explorer. Let's return to the source. We call level 1, or head level, or flat level, the one represented by this set of attributes. And what appears as a substructure, we call the second level, level 2, sublevel, or nested level, which is the one that, as I was saying, contains repetitive information. There can be many cities for the same country. Each level has an identifier, the attribute or set of attributes that allows identifying one and only one instance of the entity. This asterisk in country indicates that this attribute identifies each country, with its cities, identifying the complete set of a country and its cities. For example, China with its cities. But then to identify each of its cities, the country's own cities. That is done with the city-id attribute. The exclamation mark indicates for each level the attribute that best describes it. This semantic information will facilitate some automations that are not relevant here. If we wanted to manually enter the second level, let's delete the first one. When we remove this substructure, the transaction becomes flat, like the ones we created earlier. Now we can write the second level manually here. The other option to add the sublevel is to do it from the structure, using right-click, Insert Level, or Ctrl+L. Here we are asked for the identifier attribute of the level, which will be city ID. When we start typing, the names of these two attributes appear because they were already in the KB when we saved the transaction created by the assistant. When we leave the field, it automatically takes the first part of the name to label the level. And then we enter city name. The source is as we expected. In short, when we see this structure, both with the source syntax and with the graphical representation in structure, we know that a country will have many cities, and that they will be registered in a separate table. Let's look at this. There will be two associated tables, one with the same name as the transaction, to store the first level information, ID and country name, and another with the name composed of the transaction name followed by the level name, to store the information of the cities of the country. But note that this second table will have not only the attributes city ID and city name, but must also include the country-id attribute as part of the primary key. That is, this table will have a primary key composed of these two attributes. The transaction will handle the data from these two tables to display the information as we will see it at runtime. With the country identifier 3, this record is found in this table. And this is where the name China is taken from. The cities of China are easily located in the cities table, keeping the records that correspond to country ID 3. With this in mind, it is natural that the primary key of the cities table is composed of the country identifier plus the city identifier. Let's go a little further. Clearly, the country ID attribute, in addition to being part of the primary key, will be a foreign key to the country table. Let's run it. F5. In the impact analysis window, we see that we will have to reorganize the database, creating a new country table, with these two attributes, country-id being the primary key of the table, and another new table, country city, with these three attributes, where the primary key is composed of these two. In addition, country-id will be foreign key to the country table. This warning informs us that although CityID has the auto-number property enabled, it will be ignored. Therefore, we will have to enumerate CityID manually or in some other way, because the auto-number property only works for attributes that are the primary key by themselves. In this case, CityID is part of the primary key, not the only primary key. Let's proceed with the reorganization. The two tables and the program corresponding to the transaction will be created, along with a selection list, and anything else that is needed. Now that all programs are ready, let's run country. Let's enter the first country. Leave the ID at 0 because country ID will use auto number. Name, Brazil. For city 1, we have to enter this value manually since auto number does not apply. Rio de Janeiro. And city 2, Sao Paulo. If we try to enter another city with a value we have already used, such as 1 or 2, we receive an error message indicating that there is already a city with that ID. To the left of each used row, this icon appears to mark the row for deletion. We can enter as many cities as we want. Here we see 5 available rows on the screen. But we can add more rows to the grid simply by clicking here, once we have added the previous ones. After confirming, we see our first country with its respective cities and assigned ID 1. Then to enter another country, we type 0 for the ID or any non-existent value, since it will be auto-numbered. We will name it France. As city ID will not be auto-numbered, the value we type here will be kept. So we type 1, Paris, and 2, Nice. If we wanted the city IDs to be auto-numbered, we could use a rule called serial. We will discuss rules that can be specified to a transaction in another video. We confirm, and if we now edit the last country, we see it has been assigned the number 2. If we want to delete a line, for example, the one for Nice, we mark it for deletion, but we don't press delete, which would remove the entire country and its cities, but confirm. This is because when we press it, it will know that it has to update everything necessary, including deleting marked rows. Let's enter one last country, China, with its 3 cities. Here we see the 3 countries in the selection list. This is how simple it is to create and operate with a 2-level transaction. To summarize, when a transaction has sub-levels, it will have associated a table corresponding to level 1, i.e. the flat part, and a table for each sub-level. In this case, there is only one sub-level. Its table name is formed by concatenating the transaction name with the level name. The primary key of this table is the combination of the key attributes from higher levels. In this case, country ID, with the identifier attributes of the level itself, in this case, city ID. This attribute, repeated in both tables and serving as the primary key for the first one, will be a foreign key in the second one. This indicates that the 2 tables have a referential relationship. Every record in the cities table refers to a record in the countries table. The fact that it is both a foreign key and part of the primary key of the cities table makes cities a conceptually weak entity because they depend on countries to exist.